Thanks, Bruce. And I got to thank you for the shout out to modular adoption in the financial industry. I wasn't going to go there, but I can't resist. IO recently announced a big partnership with Goldman Sachs. There's a press release out there, so we are seeing adoption in that sector, and we're really proud of it. I'm the lead sustainability strategist at IO, and I'm excited to be here talking to you today. My goal, my big audacious goal, is to, even in a small way, change how each of you see the data center industry, how you see sustainability in the industry, and so hopefully in the next 45 minutes I'm able to accomplish that. I also won't really be talking about a lot of the things that we've heard over the past few days. I won't be talking about payback analysis or chiller plan optimization, airflow management, virtualization. I spend a lot of time thinking about that with my team, but today what I'm going to try to do is bump us up from the 500-foot level, looking at the facility and what goes on in it, optimizing the facility, up to the 50,000-foot level. Think about where the industry's going, think about sustainability, think about some of the big trends that we should have on our mind that may inform some of the detailed work we do on a day-to-day basis. We call it DC 2.0, and it's a major trend that we see in the industry. It involves prefabricated modular, which is to say standardized, optimized. It involves rapid deployment. That comes from prefabrication. It comes from standardization. It involves incrementally deployable, which is highly capital efficient, and also leads to greater utilization of the equipment because you can deploy over time rather than having to build an entire facility at the same time. Here's a little bit of, am I still mic'd? Yeah. Here's a little bit of what I'll be going through today. Starting with sustainability. It's a word we throw around a lot. I find myself having to define it often, and so I'll give some thinking there. I think with a slight mindset shift in how we think about the word sustainability, we can find even greater opportunity in the industry to advance. I'll talk about why it's important to do that, why it's important to consider DC 2.0 right now. Spend a little bit of time digging into PUE. There's a lot to say there. I'm going to try to show you how we're doing it a little bit differently at IO and how it's going to drive change. And then, we're familiar with convergence in the data center industry. We've talked about the IT and the facility side of the house converging. I'll talk a little bit about taking that hardware and converging it up to the user, trying to communicate there. But then life cycle as well. What we're going to see and what we're seeing today is a convergence across the life cycle of the physical infrastructure. And from a sustainability perspective, certainly considering all of the life of everything that we're designing, building, operating, and disposing of is going to be an ever-increasing part of what we need to think about. So, sustainability to start off with. Everybody take a second, and sustainability is like love, right? You know what it means, but then somebody gives you a microphone and says, tell me what love is. And it hurts a little, right? Take a minute, think about what would you say sustainability is? I would bet that for most of you, it involves taking something that we do wrong and doing less of it. It's mitigation of emissions, it's damaging the environment less. But that's a lot about what we should do less of, be less unsustainable. And it's not so much what sustainability is in the positive sense. It's like if you had a junk food addict and he went to the nutritionist and he said, I need to become more nutritious in my diet. Well, the nutritionist will tell him, first of all, cut out all of the stuff that you do wrong. Stop going to the fast food joints. But then they're going to start to have a conversation about what nutrition is. Your body needs these nutrients. This is what it takes to have a balanced diet. Sustainability, we're in the same situation here. And because we do so much unsustainable in all of our business sectors, it's easy to frame sustainability as being less unsustainable. And it's sort of like why we choose fast food, right? Immediate gratification, it's cheaper, it's easier. It's the same things that drive bad business decisions that are unsustainable that drive us over to McDonald's. And so Let's talk not just about doing less of that, but doing more of something else. Some of the definitions that are out there help illustrate this. An early definition, this is exactly get us to neutral, right? Whatever we do, let's not do any harm. Let's get rid of all the negative, right? Today we have one that tries to aim for sustainability in the positive sense. The possibility that human and other life will flourish on Earth forever. Flourish forever. It's an end goal, it's an ideal state, but it helps to actually define what's out there. And most of my time spent at work, I think about mitigating unsustainability, but every now and then I come up out of the weeds, I think about what sustainability is, and I try to think about how to use that. And in my world, what that often leads to is, how can we add strength and add resilience to the system that we're a part of? That's what sustainability is. We see it in natural ecosystems. They've got resiliency built in. There's codependence, there's symbiosis. How do we work with partners? How do we align interests? How do we strengthen the system in our operations? And I think we should think a little bit about that when considering DC 2.0, considering building out this infrastructure. The reason, because we're building it like crazy right now. We all know this. We've seen a lot of these statistics over the past few days. Intuitively, we know it too. So think about the last airplane flight you took. How long before you reconnected to data once you were allowed to? And for many of you, the flight itself was a time of connection to data, sending and receiving data. It's a pervasive part of our lives, and it's only a part of our lives for some of us. There's still billions of people out there not connected, and our intuitive sense of data connectivity leaves out the device user of data centers as well. That plane ride you took, the plane wasn't disconnected at all. It was sending GPS coordinates, it was getting updated flight plans, it was running engine diagnostics. It might have detected an anomaly, diagnosed it, ordered the replacement part, scheduled the maintenance window, all for its next time on the ground, all while it was in the air, all in one of our data centers. So the demand here is and the build out that we're going through requires us and gives us the opportunity to think about doing it better. Let's think about other infrastructure build outs as a touch point. Maybe we can learn a little bit about what we did in the past. What you have here is per capita passenger miles driven over the past 40 or so years. We built out the US highway system to accommodate driving, and to no surprise, we got a lot of driving as a result, and you can see 20, 30 years of it, highly dependent on the financial situation. The gray bars there showed time of recession. You can see it's correlated highly to that. And so we build more roads. What do you get? You get more cars, you get the need for more roads, you get sprawl, you get congestion, you get smog. And then the nice thing here is this is a success story. Then you get a separation from economic times and people doing things a little bit differently. 2005, we reach peak passenger miles driven per capita in the United States, and it starts to drop. That's not tied, that's back when the economy was booming, so something else is coming into play. That's because we changed a mindset from thinking about trying to build road infrastructure to accommodate driving to thinking about transportation. It's not about roads, it's about transportation. It's what the user needs. It's more than just road building and bigger machinery to build roads better. It's mass transit, it's urban design, it's dense design. It's putting a light rail into the center of Phoenix that they're doing now to try to promote different kinds of transportation and not just focus on building roads more efficiently. Here's another one that I like. Demand for data scientists. It just shows, again, what we're going through here. Imagine when all of these data scientists get to work, calling for more data, manipulating data, taking data to create more data in the process. So, same way we need to think about not just road building, not just infrastructure building at the ground level, but what the user demands from us. User demands data center services. We need to start integrating all the way up to the user, from the IT, from the facility, all the way up to the user through the application layer. That's how we're going to drive change. That's how we're going to rethink how we do things. This is what we do today. Like I said, we're looking at the facility. We're trying to optimize what's in the box. I spend a lot of my time doing this. It's important, but it leaves out a huge part of the picture. The user primarily, all of the other interdependent systems, all of the ways that we can do things smarter by not focusing on that isolated optimal solution, but a globally optimal solution in what we do. And I'm going to drill in here a little bit to PUE. I said I'd stay at the 50,000 foot level, but I think this is important. What we do now is we take a facility, we label it with a PUE retroactively on average. So a year goes by, a month goes by, you end up with a PUE. But that's like issuing an MPG rating for a car as it comes out of the production facility. It's not the MPG dashboard in front of you as you drive that actually changes user behavior. So PUE 2.0 aims to do that. Let me talk about PUE, I know we're all familiar, but just in case there's anybody out there. PUE, power into the facility, power to the IT equipment. Definition, I'm a visual learner, so here you go. It's the big arrow over the small arrow. As it gets closer to 1, you're doing a better job. The usefulness of the metric has been called into question, either for trying to compare the same facility over time, for trying to compare facilities to other facilities, apples to oranges issues. And so we need to start digging deeper into it. What if a software writer instead, well, I'll get to that in a minute. First, a quick PUE math break for you. I'll tell you why I'd prefer potentially a higher PUE in a facility than a lower one. So 2 facilities here, facility A, facility B, each of them 10 kW to the information technology equipment, ITE. We know our math, facility A 1.1 PUE, facility B 2.5 PUE, multiply them through, 11 kW power input to facility A, 25 power input for facility B. It would lead you to think facility A is the one you want to own. But let's layer on something else up at that application user layer that we need to integrate towards. What about useful work? However the application writer defines it, what sort of useful work is coming out of that IT equipment? 2 units of useful work versus 5. All of a sudden the tables have turned, and you'd prefer to be running facility B where you're getting a useful amount of work for less power in. Yeah? That's the question. Now that's up to the software writers, the applications, the users. We have created the hooks in our PUE calculation so that useful as defined by you is something you can immediately grab onto and translate. So DC 2.0 allows us to make this PUE calculation more useful, as you say. And it comes because of this standardized modular footprint, but a lot of what I'm talking about today is this intelligent control layer around the operating system, the software around the physical infrastructure. Because you have standardized modules, and because you have the operating system to measure all the data coming out of the modules, you have the ability to drill in and assess a PUE per server in a facility, even in co-location facilities, even with shared equipment. Drill all the way in, get that application writer a PUE, and of course we know PUE leads to total energy consumption. It's the backbone of all of the calculations that we want to do, the true energy consumption of that server, even in a co-location facility, even with shared equipment. And it's no different than doing an embedded energy analysis for anything else that we do. I can tell you how much embedded energy is in the aluminum in your iPhone. That's because there are standardized processes for getting the bauxite to alumina to aluminum to the component manufacturer shipped to you. As long as you know the performance of each of those discrete steps, then you just multiply through by the amount of grams in that iPhone, and you can talk about total embedded energy. It's exactly analogous. We have discrete steps here, and everything that the green grid says you need to account for in a PUE calculation happens within the walls between input and output of one of our standardized modules where we have the data we need in real time. So data in, input, output, PMOD, for example, power comes in, UPS backed up, the power needed to run the auxiliary systems in there, the lights, the air handlers, power distribution, over to the data module input, power taken off again to run the auxiliary, the AHUs, the lights, the security, the fire suppression, the whips to the server gives you the IT equipment input. All of that supported by a chilling infrastructure, and you need to know how much power it's taking into the chiller infrastructure to get a unit of heat removal capability and apply that across the board. But it's standardized processes with data in real time on each end that allow you to translate to the user in real time, even in shared facilities, even with shared equipment, the actual energy consumption of what they're doing. What does that give you? Well, you can trend over time, specific, not a facility average for the month, but a trend line per server of how you're doing on energy consumption. Because it's standardized, you can compare module to module. You can compare a module in New Jersey to a module in London and think about why are they different. You can scatter plot all of your modules and start looking for outliers. We heard about the 80-20 rule before. Let's look at performance. Let's look at performance over time. Let's figure out the ones that we need to drill into. Figure out that maybe it's a fan control issue and make sure we update that across the whole standardized hardware footprint. Those software updates, either by the application writer in terms of what is useful, or control algorithms, can be replicated immediately across the entire infrastructure. You can calculate the carbon benefit of that. PUE in real time is the foundation of all that we want to know to some extent. It's the real input. Our systems take energy, they take power. And so as long as you know the real embedded power of that IT demand, then you can start extrapolating to carbon. You can bill in real time. Customers no longer need to think about billing multiplier or flat rates. This is the miles per gallon indicator in your car that's telling you in real time how your driving is doing. And billing, well, imagine if you drove based on unlimited gas on a flat fee per month. We wouldn't be talking about miles per gallon like we are. You wouldn't have the dashboard. Changing billing to real-time actual use billing links the application and the user all the way through the stack and to the wallet. And that's how you get change. You get the information to the user, you get the incentive to the user, and that's how we as an industry can drive change. And again, I want to touch on it, but I mentioned it earlier. We want to think not always about less on sustainability, but about creating more sustainability. And that's an important consideration, and it brings to light opportunities in the supply chain, in the life cycle, like I talked about. I want to walk through each of the steps with the remaining time here, and what I want to do is highlight information flows, how these different discrete parts of the process should stay connected to one another with information. And I also want to give an idea for how each can think about sustainability in the positive sense, adding strength and resilience to the system they're a part of, however that system is defined, in order to find opportunities. And I'm actually going to do it in reverse. So, end of life, we heard a bit about it. There are some gentlemen here who can tell you a lot about it. This is something we're going to increasingly need to consider. End of life should certainly be informing beginning of life. We should not think about technology refresh as simple as throwing things out and putting in the better. that throw out process is going to come under greater scrutiny, and so we need to be designing knowing about what's happening there. Now, if we do that properly, we can add sustainability to the system. We can have refurbish in place, we can have upgrade in place, we can have the operating statistics of the fan, for example, verify that it's still fit for future use in another industry, and supply that fan to an aftermarket source. And for what can't find another useful life as it is, we can recycle that, and for what remains beyond that that needs to be properly disposed of, we need to do that very considerably. This is where we focus a lot of our time on the operating side. And certainly we need to take operational data, and with a modular footprint we're finding this is highly valuable. Standardized footprint means we can simulate test results that inform our designers and our builders. We can look at what would happen if we were to change the configuration. We have a standardized footprint, so it's worth it to dig into the details. We should also be thinking about extending the operational life wherever possible. Build for higher density. If the CPU is the thing with the quickest turnover, let's not scrap the whole data center because the CPU is no longer up to it. Let's plan for greater density, higher thermal density, new technologies, and build into the same infrastructure without having to scrap every time. And how can operations help add sustainability to a system around it? Because of our significant load and our load profile, and because we've got on-site generation at most of our facilities, we have an opportunity to strengthen and add resilience to the utility grids around us. Think about the value to society that we can provide by participating in demand response markets. Think about avoided outages and how helpful that is as an industry when we start really engaging and aligning our interests with the power providers around us. That's an opportunity to strengthen and add resilience. Everybody who builds a data center should at least go through the experience of unbuilding a data center. They should know how they're doing it and why they're doing it a certain way, know what headaches they're causing at the end of life. The build process should add strength to the local community. We should be pursuing local materials, local labor. Think about the strength, in our case at IO, to the local community of adding hundreds of high-quality jobs over the past few years in Phoenix, which was hit exceptionally hard during the recession. On the design side, here's where I think we have an exciting opportunity to align interests with our suppliers. As a data center industry, we should be pushing them to innovate in their designs, whether that's, like we heard about yesterday, immersion cooled technologies and needing the hardware to keep up. This is where we can drive industry change, and we add strength to the entire economy that way in as follows. Data centers will be, and are and continue to be, a beachhead and near-term market opportunity for a lot of technologies out there. There's a chicken and egg situation, all of us know this. A new breakthrough technology needs market validation, needs field verification in order to be adopted, but they need somebody to adopt it before they can ever look back and show you that yes, it works. We have the need to innovate, we've got a pace of change, we've got energy demand, we've got the bills that drive us to want to pursue these new technologies across the board. Data centers will be the first place where commercial scale natural gas fuel cells come to play. First place where commercial scale energy harvesting happens. Low grade waste heat gets recaptured and used. We have a chance to pull in and provide support for these early breakthrough technologies that we can't overlook. That strengthens the entire building sector because those same technologies then permeate through to the rest of the building stock. And all that we do in design should also be informing things like prefabricated modular design and how that eliminates waste and construction inefficiency. The lack of communication you see in the building sector between design, build, operate, usually those are each siloed, and the players are not talking to one another, and that leads to drastic inefficiency. The fact that we've, as an industry, been able to overcome those communication barriers is an example to show for the rest of the building stock. So I'm going to leave it there, and I'll take some questions. Thank you. Yeah.
When you measure your PUE on these units,
yeah.
What formula are you using?
We're going to be releasing a white paper on the formula. It involves looking at the real-time performance characteristics of those modules and attributing the end ITE KW demand, attributing a burden, we call it, a dimensionless burden, sort of like a PUE, power input over power output for each of those steps, attributing that to the end result, and that's how we get it. We'll be releasing a white paper that describes it in great detail. We'll also be releasing a formal algebraic proof that demonstrates its equivalence to the green grids method.
What can we expect to see in numbers on that?
In terms of PUE performance of I/O.
Yeah.
I'm not really at liberty to say. It's all across the board. We're tracking it and measuring it, but here I'm not at liberty to disclose. Yeah.
So as we talk about sustainability, and certainly your economic impact of all this in terms of a lower cost data center, to what degree do you find the clients you work with are also interested in the bigger picture of how it strengthens communities and drives?
Yeah. I think, like we heard from Wells Fargo, there's a very large amount of brand interest in sustainability, and the broader public, with things like the New York Times article, the broader public is becoming aware that we need to not look just at community service days, right? But there's this other data center footprint part of most companies that we need to be scrutinizing. And so that's pushing customers in our direction. And some of these ideas about adding strength to systems really do resonate with them, and it's especially true overseas.
Any other questions? Okay, let's give Patrick another round of applause.
Thanks.
So we do have a break right now. Let's see, it's 10 minutes.
What you feel is what you are is beautiful. Do you wanna get married or run away? I wanna wake up where you are. Yes, I'll do anything you ever dreamed to be complete. Yes, I'll do nothing that far. I'll be nothing that far all night. Wow, just slide into my room, just slide into my room. We'll be right back.